Here we are doing the average rate of change. So if we're given a function, the average rate of change over some interval, a to b, these are x values, x equals a to x equals b, then the average rate of change is just the slope of the secant line connecting those points. So change in y, fb minus fa, over change in x. It's literally just the slope of a line connecting the points, xy, xy. Change in y over change in x. For example, say we have the function f of x is x squared. We want to find the average rate of change from 2 to 4. Well, we plug in f of 4 minus f of 2 over 4 minus 2. Change in y over change in x. Those are y values on top, x values on the bottom. We get 16 minus 4 over 2, we get 6. 12 over 2. Okay, we could look at that on a picture. Here in blue is the graph of y equals x squared. Here are the points we were considering, 2, 4 to 4, 16. So our x interval was from 2 to 4. The average rate of change is just the slope of this secant line here, the slope of the line connecting those 2 points. So that's just change in y from 16 to 4 over change in x, 4 to 2. Okay, another example. We want the average rate of change of this function. G of x is 2x squared minus 3x plus 5 over the interval from negative 2 to 5. Remember, those are x values, negative 2 to 5. Then the average rate of change is g of the bigger minus g of the smaller, g of 5 minus g of negative 2 over 5 minus negative 2. And if we plug in 5 into g, we get 40. You can check that on your own. Plug in a negative 2 into g, you get 19. So on top, we get 40 minus 19, 21. On the bottom, 5 minus a negative 2 is positive 7. 21 over 7 is 3. The average rate of change of this function over this interval from x is negative 2 to x equals 5 is 3. Okay, a couple of concrete examples. Let's say you drive 100 miles and it takes you 4 hours. Well, what was your average speed? It's obvious, right? 100 miles in 4 hours, you're going 25 miles per hour. Are you doing 25 the whole time? No. No, that's your average speed. Just your change in distance, your change in displacement over your change in time, or change in position over change in time. Change in y over change in x. So speed is an average rate of change. Okay, so here's a concrete example. We have a rocket whose height in meters is given by s of t is t squared plus 5t. For t greater than or equal to 0, our time is measured in seconds. We want to find the average speed over the first 10 seconds after liftoff. So from t equals 0 to t equals 10. Then the average rate of change is just the change in height, s of 10 minus s of 0, over the change in time, 10 minus 0. So s of 10 is 150, s of 0 is 0, 150 minus 0 is 150. On the bottom, 10 minus 0 is 10. We get an average rate of change, an average speed of 15 meters per second. The top, height's measured in meters. The bottom, time is measured in seconds, so 15 meters per second. So that's all average rate of change is, just change in y over change in x using the 2 different x values that you're given.